Prove the identity cos alpha over 1 plus sine alpha plus 1 plus sine alpha over cos alpha equals 2 sec alpha. So that's in, you kind of got something plus its reciprocal equals 2 sec alpha. So with something like this, again, it's asking to prove the identity. So in my personal mind, I'm thinking I need to start with the left-hand side, everything on that left-hand side, work with it as much as I can, and turn it into the right-hand side. So it's worth knowing what sec alpha is. So sec alpha we know is 1 over cos alpha. So 2 sec alpha must be 2 over cos alpha. So we have something like that. It's just good to know what the target is in mind, where we're looking to get to. Because if you just say, well, I'm looking to get to 2 sec alpha, it might not compute quite so easily in your mind. So this is where we are heading, and just look at that. It's just one simple fraction, right? So on the left-hand side right now, we have a sum of 2 fractions. So the best way to turn the sum of 2 fractions into one fraction is just to actually add the fractions. So we're going to add those, and looking at there's no obvious nice common denominator. The common denominator is going to be 1 plus sine alpha cos alpha. So we're going to begin. Cos alpha over 1 plus sine alpha plus 1 plus sine alpha over cos alpha equals. So now we're going to add those fractions. So we're going to cos alpha times cos alpha is cos squared alpha plus, because it's all positive, you have 1 plus sine alpha times another 1 plus sine alpha. So at this point, I might just call that 1 plus sine alpha squared over 1 plus sine alpha cos alpha. So now looking at it, it does look like we're probably going to have to expand this term, and we're hoping to get a situation where we're going to have a sine squared alpha plus cos squared alpha equals 1, which will help us a lot. Okay, so now we have cos squared alpha plus, so you've got 1 times 1 is 1, sine alpha times sine alpha is sine squared alpha, plus, well then you've got 1 times sine alpha plus another 1 times sine alpha, so that's going to be 2 sine alpha. All over on the bottom. And if you look at the bottom and we look what I'm aiming at, I'm still not going to expand this, because if you just look here, we're hoping to leave this cos alpha. So that probably means we're hoping something's going to cancel the 1 plus sine alpha out from the top. That is the plan. So over 1 plus sine alpha cos alpha. Just like that. Okay, so I'm just going to rewrite these. You might not need it for the next step, but remember this is a proof, so we're trying to show the examiner or the reader. You're trying to explicitly demonstrate your understanding. So you're really trying to sort of show there's no question of whether you know what you're doing or not. So this is, I'm just going to rewrite this: sine squared alpha plus cos squared alpha plus the 1 plus 2 sine alpha all over the same denominator, 1 plus sine alpha cos alpha, right? So if we just tidy up this numerator, sine squared alpha plus cos squared alpha is 1. So we might even just show that we know that that's 1. So now this equals 1 plus 1, which is 2. So this is going to be 2 plus 2 sine alpha over 1 plus sine alpha cos alpha. And if you just remember what we are aiming at, we're looking to just have a 2 on the top and a cos alpha on the bottom. So that means we want to cancel out the 1 plus sine alpha, and if we factorize the numerator, that will enable us to do it. So you can see we've got a common factor of 2 on the top, so that will be 2 brackets 1 plus sine alpha, exactly what we want, over 1 plus sine alpha cos alpha. Okay, so now we've got it exactly where we want it, show the cancelling, and we finally have our 2 over cos alpha, which we're aiming at, but we need to make sure we show that we know that it's what we're aiming at. So we need to show that it is 2 sec alpha. So equals 2 sec alpha as required.